Yes, welcome everyone for the mineralogy lab. In previous class, we had discussed all the physical properties of minerals. So today we will see actual the mineral specimens and we'll try to identify those properties in the mineral. Okay, so the first one is the quartz varieties. Okay, varieties of quartz we are going to discuss. So here uh, the main properties what we have to understand is the color, streak, luster, diaphanity. So these four are the light dependent properties we have discussed in the previous class. Okay, then specific gravity, hardness, cleavage, fracture, tenacity. These are again the important properties which will help us to identify the physical properties of minerals. Okay, to identify the mineral, these properties are very important. Then a few more properties are like form, then chemical composition, crystal system, occurrence and uses. So all these properties we are going to discuss today. So I'll start with the quartz group of minerals. Okay, so here the common properties we'll see first. I'll show you all the quartz varieties. So here the first one you can see the color is white. Okay, milky white in color. So the name of the quartz is milky quartz. Okay, then this one color, can you identify? Anyone? What is the color of
Purple.
the specimens? Yes, purple. The name of this mineral is amethyst. Okay, it is used as a gemstone because of its color. Okay, then one more, that is smoky black or smoky brown in color. So the name of this mineral is smoky quartz. Then we have one more which is rose pink in color, light pink, which looks like rose. So it is called as rosy quartz. Okay, then this one is jasper. In this jasper, these specimens which are available in our lab that I am showing you, they occur in varieties of color. Okay, the first property I'm telling you, that is color. Color is when the light falls on the mineral, then few radiations are absorbed and few are emitted. So whatever is emitted, that we see as a color. So this is one more quartz variety which is red in color, that is jasper. Okay, that is a quartz, and this black color bands you can see on it. Okay, so those black color bands are of hematite, which is a iron ore. Okay, hematite is a iron ore mineral. So that is not, let us concentrate only on jasper first, which is red in color. Okay, then this is one more quartz whose name is agate. Okay, this name is agate, which occurs in again varieties of colors. Okay, one special property of agate is it shows bands. Okay, it shows bands. So if you see it clearly, it is not clearly seen in this image, but it has blue color bands on this. So agate, if you see the other photos of agate, you will see beautiful pictures which shows banded structure. Okay, bands are formed on this. So that is a agate mineral. The speciality of this is it shows banded structure. Then this is one more whose name is flint. Okay, flint is again a quartz variety which is very dull, you can see. Okay, which is very dull, and its color is light pink in color. Okay, then one more special property of this, you can observe it has very sharp edges. Okay, so the earlier man who was living in cave, he has used this for hunting purpose, for killing animals. This specimen was used. Okay, the name of this is flint. Okay, then one more is chalcedony. Okay, which is green in color. Okay, then opal. So all these are varieties of quartz. So I'm telling you all these are quartz. Okay. Why? Because their physical properties are same except the color. Okay, so such minerals are called as allochromatic minerals. Okay, so we'll see one by one. So this is milky quartz, smoky quartz, okay, then rosy quartz. They all have the same properties except their color. Okay, so first property is color. So whatever color is shown by the mineral, that you have to write in the exam. The specimen will be given to you and you have to write the color of that particular mineral by seeing the mineral. Okay, then next property is streak. Okay, what is streak? Can anyone tell? Streak. How do we find out streak?
Color of mineral powder.
Yes, color of the mineral powder. And how do we find out?
By rubbing.
Rubbing on?
Porcelain plate.
Yes, there is a plate called streak plate or porcelain plate on which if you rub the mineral, you can see the color of the mineral powder, and that color we have to write it as a streak. For this quartz, all the quartz varieties, okay, the streak is absent. Do you know the reason? You have studied the hardness box, hardness scale, Mohs scale of hardness. The quartz is on 7 number. Okay, if you recall, the quartz is on 7 number, whose hardness is more than the streak plate. So in such case, if you rub the mineral on the streak plate, you will not get the color of the mineral powder because it is not getting powdered, because it is harder than the streak plate. So that time we can write it as absent. Okay, then so for all the quartz varieties, the streak is absent because of its hardness. Okay, then next is luster. What is luster? We have discussed how the mineral surface looks in reflected light. So if you see all these quartz varieties, can you see how the mineral surface is looking in reflected light? So each mineral looks different. Okay, so if you see this amethyst, then this smoky quartz, rosy quartz, they shine like a glass, right? Broken glass. So what term we use to describe that? Yes, anyone? If the mineral looks like broken glass, then what luster it shows? Vitreous.
Transparent.
No, vitreous. Transparent is diaphanity. Okay. So here luster means there are two types of luster, metallic and non-metallic. Metallic means the mineral looks like a metal. But here they come under non-metallic luster. Here we have varieties of luster like vitreous, greasy, waxy, right? Silky, pearly, all these terms we use to describe the luster of the mineral. So this quartz group, okay, this shines like a glass, broken glass. So we call it as vitreous luster. Then if you see this jasper and this flint, okay, so these two, they are not shining. You can find the difference, right? You can see the difference how these are shining and how these are dull. Okay, there is no shining from the surface of the mineral, then we write the luster as dull. So you have to see the mineral and write the properties. Okay, so luster is dull. Understood how to identify luster? Then if you see this mineral, this and the one more that is green in color, this chalcedony, these two, the chalcedony and the agate, okay, this one, they look like wax. Okay, the surface, if you observe surface of the mineral, it shines like a wax. Okay, so it shows waxy luster. So like this, you have to identify the luster of the mineral. Then next is diaphanity. Diaphanity describes the transparency of the mineral. How transparent is the mineral? So if you see this milky quartz, okay, light can pass through the edges, okay, but you cannot see the object behind it. So what it is called as? Anyone? Light can pass through, but object cannot be
Diaphanetic.
seen. That is
Diaphanetic.
Translucent.
translucent. It is called as translucent. So these amethyst, smoky quartz, milky quartz, they all are translucent. Whereas this jasper, it is very hard, you cannot light cannot pass through it, right? So this flint and agate, they are flint and jasper, they both are opaque, okay, wherein light cannot pass through it and object cannot be seen, so that is called as opaque. So understood, you have to hold the mineral and see the properties. So these first four properties, that is color, streak, luster and diaphanity, they are dependent on light, the behavior of light. Okay. So you can see the mineral and identify these all properties. Okay. Then next is hardness. So this is a number, okay, which represents which is represented in a hardness box, that is we call it as Mohs scale of hardness. Okay, so in this hardness box, if you see, the softest mineral is talc, then comes the gypsum, then calcite, okay, talc, gypsum, calcite, fluorite, apatite, okay, then orthoclase, quartz, orthoclase, Feldspar, then quartz, topaz, corundum, and diamond. Hardest one is diamond, and softest is the talc. Okay, so here the quartz is there in the hardness box, right? So that is on 7 number. So you have to write the hardness as 7. For all the quartz, the hardness is 7 except opal. Okay, then specific gravity, if you find, I have told you how to find the specific gravity of a mineral, right, in the last class. So if you do the experiment with the help of Walker's Teliard balance, then you will get the answer as 2.6. That is the specific gravity of quartz. All the quartz, they have the same specific gravity, that is 2.6. Then next, cleavage. Okay, cleavage means what? If the mineral is breaking in a definite direction. I'll show you. This is a one more example I'll show you. This mica, okay, mica, it splits layer by layer in one direction. Okay, you can see the pieces lying, they are broken parallelly, like your pages of book, they split. Okay, even this calcite, if you see, okay, this you can see it has particular lines, okay, which will have a definite breaking pattern. You can see wherever it has broken with a rhombic fashion. Okay, you can see the rhombic shape here. Okay, so this is called as a cleavage, but you cannot see such a definite pattern of breaking in these quartz minerals, right? You can if you see all these, you don't have any definite breaking pattern. Okay, so that is the cleavage, you can write it as absent. Okay, so quartz is devoid of cleavage, cleavages are not present in quartz, so only the quartz is harder mineral, okay, whose hardness is 7. The less the hardness, you can find the cleavages. Okay, then next is fracture. Fracture is again a distinctive property, you can say. The mineral, it is related to again breaking of the mineral, but other than cleavage, how the mineral is breaking. So if you see the broken broken surface of this, okay, it will show or it will break in a curved fashion, that is either conchoidal or concave. Okay, so if you touch this broken surface of any of these quartz, okay, you can feel the curved surface. Okay, the broken surface is curved. Here in the on the agate you can see it, wherever it has broken with a curved surface. So when the mineral breaks in a direction other than cleavage, we call it as fracture. So fracture here, it is conchoidal. On the flint also you can observe here. Okay, the broken surface, if you see, you can see the curved surface. So such pattern of breaking is called as conchoidal. So all the quartz varieties, they break with a conchoidal fracture. Okay, next is tenacity. Tenacity means when you apply pressure on it, how is the behavior of mineral, that is called as the tenacity. So if you hit the quartz, what will happen if you apply pressure? It will break into pieces. So that is called as what? Anyone? If the mineral breaks into pieces, we call it as what tenacity? Anyone? Amrut? Mansi? Yes, if the mineral breaks easily into pieces, then it is called as Mansi.
Yes, ma'am.
Yes, what it is called as? If the mineral breaks easily, if when you apply pressure, what type of tenacity it shows?
Brittle.
Ma'am, brittle.
Yes, it is called as brittle tenacity. Brittle means breaking into pieces. Okay, so that is called as brittle. So if you apply pressure on it, if you try to break it, it will break into pieces. So we call that, we have to write it as brittle. Tenacity is brittle. Then the form, next property is form. So if you see all these quartz, they have a definite shape, crystalline shape, but these crystals are not clearly seen with the naked eyes. Then it is called as cryptocrystalline. Then these on this amethyst and all, you can see the crystal, but it is not perfectly developed. Then we use the word crystalline to describe such crystals. Okay, so here the form will be crystalline massive. Okay, this form is banded, you can write it as banded form. Okay, this also agate is showing banded form. So like this you can write the form. Okay, so this is again massive, crystalline massive form. Okay, so this chalcedony is cryptocrystalline. Cryptocrystalline means there are crystals, but you cannot see them with the naked eyes. You have to use the microscope. Under microscope you can see the crystal, development of crystal. Then such form is called as cryptocrystalline. Then next property is chemical composition. So all these quartz, they have the same composition, that is SiO2, that is silicon dioxide. So that is SiO2 is the composition of all these quartz group of minerals. Then where do they occur? That is occurrence. If you recall the chemical composition of a granite. Granite is a igneous rock. We all know that granite is a igneous rock. And if you see the chemical composition of granite, that main composition is quartz and feldspar. So in granite, you will find any of these quartz as a major constituent. Okay, so quartz, and this one is feldspar, which is the next group of mineral. So these two minerals, they are present in the granite. Granite is a rock. So that is why we are studying the minerals. Okay, so that it becomes easy to know the rock. So we know that quartz is harder mineral. So because of that composition of granite with the harder minerals it is made up of, so it is also a hard rock. Okay, white, black patches, whatever you see on the granite rock, that is all these quartz varieties of minerals. Okay, so this is why we need to study first minerals, then we'll go to rocks. So these quartz are present in igneous rock. So you can write the occurrence as it occurs in igneous rocks. Okay. Then some minerals like this agate. Okay, agate and flint, they occur also in sedimentary rocks also. Okay, they occur in sedimentary rocks also. Okay, then if you see this amethyst, okay, in my last presentation I had shown you the beautiful minerals in that. This amethyst especially it forms in cavities. Okay, while cooling of the magma, what happens when the lava cools, it contains gases also, so it forms cavities. Okay, in that cavity the mineralization takes place. So it looks like your coconut shell. Okay, outside you will find a shell, and inside if you see white color, this coconut will be there. Same way, inside minerals will be there and outside rock will be there. Okay, rounded you will find. So that is called as geoids, and these, especially these quartz group of minerals, especially amethyst and all, they form like this in cavities. Okay, then this one is opal. Opal is a quartz variety, but it is not having any crystal structure, so we call it as amorphous. It is a amorphous variety of quartz because it doesn't have any crystal structure. Okay, and its hardness is also less. It is ranging between 5 to 6. Okay, then the specific gravity is also less. Okay, so that is a opal mineral. Then the finally the last property, that is uses. We must know where these quartz varieties are being used. So main use of this all quartz is in the manufacturing of glass. Okay, manufacturing of glass. Then you must have heard there is a company of watch with the name Quartz, right? So there also it is used in watches. Okay, so glass manufacturing, watches. Then because of this beautiful color, amethyst and this rosy quartz, they are used in gemstones. Okay, gem minerals in jewelries and all, they use as a stone, gemstones. Okay, then some minerals like this agate. Okay, because of its banded form and all, it gives a very beautiful appearance, so they are used as a door handles. Then main use of this agate is it is used as a mortar and pestle. Okay, to crush the what your medicines and all, to make fine powder of medicines, right? So these agate mineral is used as a mortar and pestle. Okay, then this flint is used as a ceramic industry, pottery. Okay, then to make lighters. Okay, in the refractories also these minerals are used. Okay, then yes, some are used, yes, in main uses glass industries. Okay, so this is how you have to study all the minerals. Now I have told you how to study the physical properties of quartz group. Okay, next we'll move on to the feldspar group of mineral. In this we have three minerals, that is orthoclase, plagioclase and microcline. These are the three minerals which come under feldspar group. Okay, so orthoclase, this is one, that the color if you see it looks like a flesh. Okay, flesh or a meat. So you can write the color as flesh red. Okay, then plagioclase is white in color and microcline is pink in color. Okay, then if you see the streak, if you rub it on the streak plate, it is absent, because we know the hardness of feldspar group, that is in the hardness box, it is 6 on 6 number. Okay, so it is quite harder, okay, harder than the streak plate. So it will not produce any powder, so you can write it as absent. Then luster, if you see the surface of these minerals, they shine like a broken glass, but the shine is not like this quartz. Okay, the quartz will shine with a very bright shining, you can say, but compared to quartz it is less. Okay, so you can write it as subvitreous. Okay, subvitreous is the luster. Then diaphanity, if you see the color, whether the light, whether it can pass through or not. Okay, so if you hold the mineral in under light, then light can pass through the edges, but it you cannot see the object behind it. So all these are translucent in diaphanity. Then hardness is 6. Okay, then very important property of this feldspar is it has two set of cleavages. Okay, one you can see here, the breaking like this, layer by layer. If you see here, you can find the steps. Okay, these steps are nothing but it has broken into layers. Okay, here also you can see a line at the bottom. So this is one set of cleavage, and other set which is perpendicular to that. Okay, this one. Okay, so this is the special property of orthoclase. It has two set of cleavages perpendicular to each other. Okay, then fracture is uneven. Other than cleavage, how the mineral is broken, if you see, it has broken with a uneven surface, so it is called as uneven fracture. Tenacity is again brittle. Form, if you see, it is flat. Okay, all these three, they are flat, so you can write it as tabular or flat. Okay, so tabular massive is the form of this. Then where these minerals are used, occurrence, again I told you, this is the major constituent or mineral which is present in the quartz, sorry, granite. Okay, so in granite rock you will find these two minerals, quartz and feldspar. Okay, so these occurrence, again you will write it as igneous rocks. Okay, then the uses, if you see, feldspar, after weathering of granite, you will find the feldspar from the granite, it will form clay. Okay, it will result into clay. So the best example to know that is the Khanapur, which is very near to Belgaum, and it is famous for brick industries, right? Manufacturing of bricks. So there we have pink granites. Okay, granites we have, even gray granites are there. So these granite, after weathering is decomposition of the rocks. So they, the end product what we get from weathering of this is the clay. Okay, so it forms the clay which is rich in feldspar. Okay, so it is used in ceramic industry, flooring tiles. Okay, then it is used also in glass manufacturing, then pottery industry. Okay, so all these are the main uses of all these feldspar group. So in this we have three, that is orthoclase, plagioclase and microcline. Okay, then we'll move on to next group of minerals, that is mica group. In mica group we have two, that is muscovite, which is transparent colorless variety. Okay, if you see a single piece of this, it is very thin. Okay, then this is biotite, which is black or brown in color. Okay, so these are the two varieties of mica. The special properties, if you talk, okay, the luster is pearly. If you see the surface, it shines like a pearl. It looks like a pearl. So the luster is pearly. Then both these are transparent varieties, and the important property is cleavage. Okay, it splits into layers. Okay, it splits into layers. So it will have one particular direction of breaking. So it will break like your pages of books. Okay, it will break in one direction. So it has one set of cleavage, and that is called as basal cleavage. Okay, then tenacity, if you see it, it is very soft. Okay, when you apply pressure it will bend, and if you release the pressure it will come back to its original state. So that is called as what? Any idea? It is like a rubber. When you apply pressure it bends. When you release the pressure it will come regain its shape. That is called as yes, elastic tenacity. Okay, so that is the special property of mica. It is elastic. Then the form is foliated. Foliated means layered. Okay, then it is also found in igneous rocks. Okay, then like granite and pegmatite. Okay, these are the rocks in which it is found, but it is present as a accessory minerals. Then the important is where it is used. Okay, the muscovite mica and biotite mica, they both are used in electrical and electronic insulators. Okay, then it is shining, and because of that shine it is used in paints also, paint industry. Then it is used as in the furnace, spark plugs, lubricants. So all these are the uses of mica. Okay, main uses electrical and electronic appliances. Okay, then the next is carbonate group. In that we have two minerals. One is calcite and dolomite. Okay, calcite and dolomite. The special property of this, if you see, this calcite occurs in varieties of color again, but what we have is white in color, and the special property is its hardness. Hardness is 3. Okay, talc, gypsum and calcite, that is in the hardness box. So it is on third number. So this hardness is 3. Okay, and the special property of this is cleavage. It has rhombic cleavage, means if you try to break this mineral, it will break into rhombic fashion. Even a small piece of this, it will break with a rhombic fashion. So that is because it has 3 set of cleavages. Okay, like a cube, you can imagine it has 3 planes. Okay, in which it can split. Okay, so this calcite, it also has 3 set of cleavage in 3 direction. So it breaks into that particular fashion. So cleavage is breaking of a mineral in a definite direction. So you can see the definite breaking pattern here. Okay, so that is why it is important property. It breaks, so it is very soft. You can see the hardness is 3. Okay, so it is softer mineral, and the specific gravity is 2.7. Okay, then the chemical composition is carbonate group. I said, means it is calcium carbonate. It is made up of calcium carbonate, and the rock in which it is found is limestone. It is found in sedimentary and the metamorphic rock. I'll tell you why. Because we know the rock whose composition is CaCO3, that is calcium carbonate. Any idea? Which contains lime, which is a sedimentary rock. Anyone? The name of the rock whose composition is calcium carbonate. It is limestone. Limestone is made up of calcium carbonate, and when this limestone undergoes metamorphism, it converts into marble. So marble composition is again same, that is calcium carbonate. So both these rocks, they are made up of this calcite. Okay, so it is chemically reactive. When you put a drop of HCl on limestone, what will happen? It gives effervescence. So you have to be particular when you use the rock. The purpose you must understand, what type of structure you are building. Based on that, you have to decide which type of rock is to be used. Okay, so marble, limestone, these rocks, as they contain calcium carbonate, you cannot use it in kitchen tops or any chemical industries and all. You cannot use because it is chemically reactive rock. Okay, so these are the two minerals, calcite and dolomite. The only difference is the calcite contains only calcium carbonate, and this dolomite along with calcium carbonate, it contains Mg, that is magnesium also. Okay, so that is the only difference. Okay, then these both, they occur in sedimentary rocks, remember. Then the use, as I told you, the composition is CaCO3, that is lime. So lime is main ingredient in manufacturing of what?
Cement.
Yes, cement. So cement, the lime is used as a flux. Okay, then it is also used as bleaching agent, and it is also used in paints. So the main use of this is the cement. Okay, it is used in manufacturing of cement. Then the next mineral is kaolin. Kaolin is a clay mineral. It is clay, purely clay. If you see the color, it is buff white or cream color, you can write. Okay, the streak, if you check, it will give white streak. The luster, if you see, it is very dull. Okay, there is no shining from the surface at all. Its hardness is very less. It is less than 1. If you touch, it crumples between the fingers, means it becomes powder very easily. Okay, because it is less harder. Okay, then it is the main use of this is in paper, paint, textile industries, then in cement, and even in China ware and brick industry. Okay, these are the uses of kaolin. Then next is gypsum. Gypsum is again very important from engineering point of view. That is the calcium sulfate, CaSO4.2H2O. That is the composition of gypsum. So it is a calcium sulfate, and if you see the hardness of this, it is there in the hardness box on second number, talc gypsum. So gypsum hardness is 2, so obviously it will have the cleavages. So it has one set of cleavage. You can see it is breaking flat, okay, in one direction. So if you observe carefully, it will break in one particular direction, so that it has basal cleavage or one set of cleavage, you can write. Okay, so these are gypsum crystals what we have. Okay, then the hardness is 2, then cleavage, it has basal cleavage, then elasticity or tenacity, if you see, it is flexible. Okay, then it is the form, if you see, it is very flat, so you can call it as tabular form. Then it occurs in sedimentary rocks. It occurs in sedimentary rocks. Then also it occurs as evaporite deposit. Means after evaporation of the water from the dissolved salts. Okay, because it is a salt, CaSO4, calcium sulfate. So after evaporation, it is left out as a deposit like salt. Okay, so same way it forms. So that is if the mineral has formed by that process, it is called as evaporite deposit. Then the main use of gypsum is, it is used in POP. What is POP? POP,
Plaster of Paris.
plaster of
Plaster of
Paris,
Paris.
right? Yes, then it is The gypsum is used to make gypsum sheets. Okay. Then cement industry, ceramic industry. So these are the uses of gypsum. Then next mineral is asbestos. Okay. So this is the last mineral in your syllabus in the rock forming group. Okay. Asbestos, if you see, it is like fibers. Okay. Silk thread like. You can see, you can, if you take out some piece of it, it will come as a fibrous material. Okay. So the form is fibrous and the luster is silky. It looks like a silk fiber. So it is silky. The color is black or gray in color, but if you check the streak, it is white in color. Okay. Then the main use of this asbestos is it is used as a thermal insulator. It is a fireproof material. So in your refrigerators, ACs, ovens, it is used as a lining for that. Okay. So these are in even in chemistry labs and all, asbestos sheets will be placed on your table. Okay, because they don't catch fire, right? So these are used as fireproof material. Then even these minerals are used in textile and ceramic industry. So that is the important use of asbestos. Then we'll move on to the ore minerals. So what is an ore? Ore, any idea? O-R-E, ore. So this is a hematite. Hematite, limonite, pyrite. Okay, so all these are ore minerals. Chalcopyrite, okay, chromite,
Naturally
bauxite.
occurring.
What?
Naturally occurring.
No, all the minerals are naturally occurring, no doubt in that. Here, nothing is artificially prepared. All the minerals, what you have seen, they are naturally formed. The definition of mineral says that all the minerals are naturally occurring inorganic substance with definite atomic structure and chemical composition. Okay, so all these are natural only. What is ore? Ore means like this is a bauxite. Do you know from what bauxite what is extracted? Anyone? Or from hematite, magnetite, what is extracted?
Iron.
What? Yes, iron. So you can call it as a iron ore. So ore means what? The substance from which the metal can be extracted. So if you see all these, they have a very particular shine. So they all shine like a metal. So the luster, what you will write it as metallic. So color, whatever you see, the black, brown, red, bronze, yellow, all these colors you can see. Okay, black color. Then this looks like a gold, but it is not gold. It is a fool's gold. The other name for this pyrite. Pyrite is a mineral iron ore. So ore is what? Basically, from which you can extract the metal with profit. So these are iron ores. Hematite, magnetite, limonite and pyrite. These are the iron ores, okay, from which you can extract the iron. So it will have some impurities also. So that is called as the ore mineral, okay. Then this in this only the golden part what you can see, not the white and black one, okay. Whatever is shining like a metal, that is chalcopyrite, which is chromium ore. Chromium, from this you can extract chromium. Then bauxite say you can extract aluminium. Okay, so it is a ore of aluminium. So we'll see some special properties of all these. Okay, so hematite, if you see the color is black, but if you see the streak, when you rub it on the streak plate, you will find a particular color that is cherry red. Okay, cherry red streak you will find. That is the special property of hematite. Then luster is metallic. Okay, then the composition is Fe2O3. Obviously, all these are opaque. Diaphanity is opaque. Okay, then the important is its uses. Uses, it is an important ore of iron. So iron is very important for civil engineers, right? You can prepare from iron. You can make steel. Okay, then you the hardware, machinery, or construction purpose, everywhere you need iron. Okay, iron is the main constituent which we use in the construction industry. Then this is a magnetite. If you see the color, the name first I'll tell you magnetite. The why the name magnet is used here, because it has magnetic properties. If you hold the magnet near it, it will attract the magnet. So the name is given as magnetite. If you see the color is black, if you check the streak, it is reddish in color. Okay, so that is the magnetite special property. Then its composition is Fe3O4. Okay, then this uses, it is an important ore of iron. Okay, then this is also important ore of iron, that is limonite. Limonite, it shows varieties of colors, like it shows shades of brown, black. Okay, then if you check the streak, it is yellowish in color, yellowish brown in color. Then luster, if you see, it is metallic or submetallic. Then it is again an important ore of iron. Okay, but it is a low grade iron. Low grade means you will not get more iron content in this. So that is a limonite. Then its occurrence, if you see, it is the form, if you see, it is radiating, okay, or globular. If you see this particular face of this side of the mineral, it has a very beautiful structure, wherein you can see needle like structure is coming out or radiating from a common point, and each of that such structure has a globular form. Okay, so that is a limonite. Then the important is pyrite, which is also called as fool's gold. The color is bronze yellow, but if you check the streak of this, it will give a greenish black streak, black color streak you will find on the streak plate. If you rub the gold, you will not get streak on the streak plate for the gold. But pyrite, if you rub, you will get the black color streak. So if you go to any goldsmith, you will find this particular streak plate with him. First, when you take your gold, then he will definitely check whether it is a gold or pyrite. Okay, so that is how we can identify the different minerals, right? You can differentiate with the help of a streak. Okay, so this pyrite, it is cubic in form. Okay, cubic structure you will see on the surface of this. It is made up of cubic structure. Okay, so it is FeS2, that is iron sulfide. So because of the S content, sulfide content, it is used in the manufacturing of sulfuric acid. That is the main use of this pyrite. Then next is chalcopyrite, which is a copper ore. Okay, it is a copper ore whose color is brass yellow in color. Yellow is golden in color. But if you check the streak, again it will give black streak. Okay, then its content is CuFeS2. So if you see this pyrite and chalcopyrite, they occur together. They are associated minerals. So usually they occur together, CuFeS2. So if you find the content of iron in this, then iron and copper, you will call it as a chalcopyrite. If only iron is present, then it is this is pyrite. Okay, pyrite and chalcopyrite. So chalcopyrite is a ore of copper. You have to remember it as it is used as important ore of copper. It is used in electrical industries. Then you can make different alloys from this copper. Okay. Then the next is chromite, that is chromium ore, which is whose color is black, but if you check the streak, it is dark brown in color. Then it is a ore of chromium. It also contains iron. So FeCr2O4, that is the composition of chromite. Then the important use of this is it is used as an important ore of chromium. So it is again used to make different alloys. From that you can make. Then the last mineral, that is bauxite. So bauxite is a aluminium ore. So you can extract aluminium from this. Okay, so that is used in refractory, electrical industry, to make utensils, etc. That is the use of aluminium, right? So its composition is Al2O3.H2O. Okay, then the important property of this is its form. You can see the rounded mass on this. It always occurs like this with a spherical surface, the circular structure on the surface. So that is because that structure is called as piezolytic structure. These circles are of p size, so it is called as piezolytic. So rounded structure you can see on the surface, then it is called as a bauxite. Okay, piezolytic bauxite. So piezolytic is a form of that particular mineral. Okay, so usually this is found in subtropical to tropical climate zone. Okay, and it is the important ore of aluminium. Okay, so these are the all ore minerals from which you can extract metal, and these are all the rock forming minerals which are present in the rocks. So these are all there for your syllabus, which you have to see, identify and write the properties of that in the exam. Okay, any doubts?
No,
No,
ma'am.
ma'am.
No, ma'am.
Okay.